This section goes over an example problem to explain the concept of equilibrium of a two-force body. Simply, this is a case where an object is at rest or in equilibrium, and there are two individual forces acting on it at the same time. Since we know the quantity of forces, the main concern is to figure out what magnitude and direction the two forces possess. For our example, we will say the separate forces are called A and B. We will be determining the relationship that exists between the two so that this object can remain in equilibrium. Notice here that A has a specific direction with an origin of point Q, but B is represented with a wavy line since the direction and where it acts on the body are both unknown. The variable D represents the perpendicular or normal distance from the force B to point Q. The first step is to establish a suitable coordinate system. We will set the positive y direction to be upwards, the positive x direction will be to the right, and positive moments are counterclockwise. Next, we will determine which section of the body needs to be examined in greater detail. In this example, it is just the entire body itself, so no further assumptions need to be made. Then, we will solve any associated equations. Recall that the three aspects of any force are magnitude, direction, and location. We will first determine the magnitude and direction of the two forces. For the x component, the sum of the forces must be 0, so bx is equal to ax in magnitude, but they will act in opposite directions, and therefore bx will be set as negative while ax has a positive sign, according to our coordinate system. Similarly, for the y component, the sum of the forces must be 0, so by is equal to ay in magnitude, but they will act in opposite directions, and therefore by will be set as negative while ay has a positive sign because of the coordinate system we set. We have now determined that the force B is equal to A in terms of magnitude and the exact opposite in direction. Now, we can find the location that force B is acting on in reference to point Q. To do this, we will take the moments about Q, and since the object is in equilibrium, we will set this equal to 0. Since A is already acting on Q, we now know that A produces no moment. So, we can just set the sum of moments equal to the magnitude of force B times an unknown distance. The magnitude of force B cannot equal 0 because we have already determined that it is equal to force A, which is not 0. This means that the distance must be 0 for the moment at Q to be 0. We now know that the location of force B lies somewhere on the same straight line as force A, which is termed collinear. Finally, we will sketch and interpret the results we have found. In summary, force B must be equal in magnitude and opposite in direction to force A, and the two forces are collinear, but otherwise we cannot determine the exact location of force B. So the forces acting on the body would appear like this.